Welcome back. In this video I'm going to have a shot at explaining the various limits and stops that you have to set for this machine to operate correctly. Now the first thing we want to do is set the mechanical limits, the actual physical stops. And to do that I would suggest, and this is the linear encoder here, I'd suggest undoing this from the tower base, so that when you range it you don't smash it through the end stops, the end limits of this encoder. So having done that, you can then use this hand wheel in my machine to manually move the slide to its extremes. Now it's possible on this, if it's not set up correctly, to wind the recirculating nut right off the end of the screw inside this part here, or crash the nut into the ends of the other end and maybe crack some balls in it. So first of all you want to make sure that you know where those limits are, and the mechanical stops should be obviously inside that, and set them so you've got a little bit of clearance of there's a prong here that goes up into to pick up off the encoder, and so you make sure that that's maybe 5 or 10 millimeters short each end, so you don't smash out the end of the encoder. So let's go around to the other side of the Y slide and have a look at the limit switches. The next thing we're going to need to set are these limit switch cams here, this black one here behind this one, and over here, this one here. Okay, and they are triggered by this switch here. But before we do that, I'm going to have to switch the machine on. So let's do that process. Clear entry here, come up here and push power on, and here we have it looking for reference marks. We push this guy, it's hunting for Z, and it's found Z. Push it again, it's finding Y. And push it again, and it's hunting for the X-axis. Okay, so now it's found the reference marks and it's in actual mode, which is the encoder position relative to the datum I set for the last part I was machining, and I don't really want that, so I'm going to press the mode button, and I've got vacant blocks. Now here I'll press down a couple of times, 1, 2, and there we've got position data. So now when I press enter we get reference or whatever. I can go through them, and I want it on reference, and I'll say del. So now you can see what it's done is it's actually overshot. This is where the reference datum is, and we're just a little bit off because of course once the machine is found or passed over the datum, it needs to stop, so it's just overshot a little bit. But now we're actually measuring the encoder position relative to the reference marks or the index marks on the encoder. So here we are, having just finished the finding reference, and you can see that the switch for this cam here has been hit. The search sequence I've mentioned in another of these videos needs to find the index mark somewhere on that cam, so this is just within range. Now in this reference mode is when we set these black cams in the position they should be, right? It's a bit hard to see, it's underneath there, each end, and they work on a switch round behind here you can't see. Okay, now what I'm going to do is reach around like that and push that button, and you'll hear what happens. Okay, the servos have unlocked. They've dropped out. The black cams, these are the ones you set inboard of the mechanical stops, so you don't crash into the mechanical stops. It's interesting to note that the Heidenhain knows nothing about these cams on the 3 axes. They're all in a daisy chain. If they trip, it trips out the contactor for the servo motors and they switch off. The result is there's no control braking. The slide then just coasts to a halt, and it does so. On my machine it takes about 10 millimeters before it stops. So if you don't have these set right, you'll still crash into the mechanical stops. So these should trip at each end. They should trip this axis, or any of the 3 axes, about 10 millimeters before you hit the hard stops, or you'll crash into them and probably, it's a big heavy slide, it's liable to damage things. So these need to be set to trip the servos about 10 millimeters inboard of the mechanical physical stops. So we've set 2 lots of limits, the mechanical and the limit switches. Now we can look at setting the software limit switches, and we want them to be just inboard of the limit switches so that we don't actually have to drop the servos out. Now the Heidenhain knows about the software obviously because it's in its software. So let's just try going, I'm going to go to the furthest away, which I think is what, 353. So I'm going to go in the Y direction, 353. We'll just run it at the maximum axis traverse speed and watch what happens. And there we got it, 353. It's actually obviously done an approach to it and stopped right on the limit, and we can see we're on the minus limit switch. Now we've come around and we're looking at here, and you can see that the limit switch has not quite been hit. It's just stopped very nicely without having to drop the servos out. Perhaps it's worth noting that one of the reasons that it approached the set point correctly is that these 8 blue buttons here for the 4 axes this machine has have direct inputs to the Heidenhain. They're not external, they're actually only connected to inputs on the Heidenhain. So it knows how to use them to approach that 353 limit correctly. Conversely, these 4 buttons, the coolant off, coolant on, and spindle stop and spindle start, are wired in parallel with the outputs of the Heidenhain and for their corresponding functions. And the Heidenhain knows nothing about it. And I think the reason for that is, in the old days when this was being sold, the client usually asked if you could run the machine purely by hand in case the computer failed. And this is the response to that. Now we've done the mechanical limits and the limit switches, it's time to set the software limits. And to do that, we simply start the machine and get it up and running. We shift it into the reference mode as described earlier, and in my case I just wound the remote hand wheel carefully to shift the traverse, each traverse, to close to the limit switch as we've seen. So as we can see, for the minus Y position, minus 353 millimeters away from the reference point, is suitable for that particular software stop. Then you have to repeat that for the other 5 positions and record the numbers so that you can later put them into the required machine parameter numbers. I've explained in other videos how you manipulate the machine parameters, and you can see from this printout from my manual the 6 numbers that I've actually put in parameters 44 to 49. Once you've set those parameters, a Heidenhain will know to never go beyond those points no matter what you change. It will not go beyond them until you get in and change those machine parameters. If we come back here a little, we can see how massive the Z-axis rotary table and the knee of this machine are. Something like 600 kilos. As a result, it doesn't really lend itself to having mechanical stops so massive that it's liable to smash them. So we can see here, down here, it has the same limit switches and so on, and you can set them the same except there's no mechanical stops. To compensate for the lack of mechanical stops, this servo has built-in electromechanical brake, so it's always in brake mode if it's not in the servo mode. When the servo mode comes on, the brake automatically gets disengaged. Another note, it turns out that the circulating ball screw on this axis is so efficient that if this brake on the servo doesn't work, the Z-axis starts to overrun of its own accord under gravity and comes increasingly faster until it smashes into whatever at the end of its travel. So logically the brake works as it should and stops that runaway, except if the belt that drives to the ball screw from that servo breaks, in which case the brake is no longer connected to the Z-axis. To overcome that, there's a belt sensor arm that meshes in as a jam brake on the Z-axis pulley in the event that the belt breaks. So for your information, I've included part of the schematics for the 3 cam switches on the X, Y and Z axes, 8S1, 9S1 and 10S1, which have to be closed or not on the cam for this part of the diagram to complete. And you can see that when you push the power on button for the machine, if they're in the correct position, 7K1 contactor coil will energize. Okay, I think that's enough on this topic for today. Hope you've found it informative, and I think I'll leave the discussion there. Thanks for watching.